A wheel weighing several tons glides smoothly for decades. A single rail, stretching 330 feet and weighing over 13,000 pounds, endures tens of thousands of crushing loads without yielding. This extraordinary strength is no accident. It is the culmination of a long and fiercely complex metallurgical journey designed to forge resilience from raw elements. The process starts deep underground, with ore pulled from the earth. It is carefully blended with coke and other vital additives, then charged into massive furnaces that roar with extreme heat. From this inferno, glowing molten steel is born. The liquid metal is painstakingly refined before being forced through rollers, which shape it with exacting precision into its distinct profile of head, web, and foot. Next, the newly formed rail undergoes critical heat treatments to temper its structure. Individual lengths are then welded into continuous ribbons, stretching for hundreds of meters, before facing a final battery of rigorous inspections. Lasers, X-rays, and ultrasound technology scrutinize every inch, searching for any flaw that could compromise its purpose. Forged in fire, they carry the weight of nations. These ribbons of steel are more than just pathways. They represent a colossal economic engine, a vital link in the chain of global transport. In 2023, the worldwide market for rail steel was valued at around $15 billion. Forecasts suggest this figure could climb toward $20 billion by the year 2032, a testament to the enduring power of this industry. This immense value reflects a global investment in railway networks. It fuels the rapid expansion of infrastructure across Asia and drives the strategic imperative to modernize over 140,000 miles of track in the United States alone. The sheer scale of production mirrors this economic might. Each year, the world's furnaces yield roughly 2.1 billion short tons of crude steel, with a significant portion of American output meticulously shaped into rails for both domestic and international lines. But these are no ordinary steel products. Each rail is engineered to endure the immense, repeated loads of passing trains for more than 20 years, acting as a lifeline that ensures the stability, safety, and efficiency of the entire network. From a simple block of steel, a new form emerges, sculpted not by hand, but by immense calculated force. The billets plunge into vast reheating chambers, a critical stage that stabilizes the metal's internal structure. Inside these fiery halls, the temperature is held above 2200 degrees. High-powered burners work in concert with infrared sensors, which constantly scan every point on the billet surface to ensure the steel does not cool too quickly. Even a fractional drop in temperature could cause the surface to harden, inviting cracks and deformation in the moments to come. Once stabilized, the billets are propelled onto the rolling preparation line. Here, enormous heat-resistant rollers, driven by hydraulic motors and heavy-duty gearboxes, begin to shape their length and cross-section. The entire system is programmed to fine-tune the pressure and rotation speed for each pair of rollers, distributing force evenly to prevent localized stress. What unfolds is a seamless integration of mechanics and electronics. A central control computer digests real-time data from dozens of sensors, instantly adjusting the process with inhuman speed. Every movement aligns with the precision of a clock's gears, producing billets that are elongated, flattened, and ready for their final transformation. As they exit the furnace, the glowing billets are fed directly into the main rolling line. On a network of heat-resistant tables, the steel enters the roughing mill. Massive alloy rollers with smooth machined surfaces, pressed down with thousands of tons of force. The thickness is drastically reduced as the length stretches out, preparing the billet for more precise shaping. Next, it passes through intermediate stands, where the profile is gradually refined. Here, rollers in alternating positions compress and twist the steel, evenly distributing stress and eliminating any dimensional errors. In the finishing mill, rollers with specially engineered grooves begin to sculpt the rail's classic eye-shaped cross-section. This iconic design delivers remarkable strength while keeping the overall weight manageable. Between each stage, high-pressure water jets blast the steel, cooling the surface and clearing away oxide scale to maintain temperature stability. Along the line, laser sensors constantly measure height, width, and straightness, feeding real-time data back to the central system, which adjusts roller gaps and speeds with pinpoint accuracy. A standout feature of this process is the ability to rapidly swap out roller sets, allowing the mill to switch between different rail profiles without halting production. This stage is decisive, locking in the rail's final geometry and ensuring every piece meets exacting standards. Still glowing red from the ordeal of rolling, the steel rails carry significant internal stresses. The cooling and heat treatment that follow are the critical steps that will forge the product's true backbone. Immediately after leaving the mills, the rails pass through a high-pressure water spray system, where a dense mist envelopes their entire surface. Both the speed and volume of the water are tightly controlled to guarantee even cooling along the full length, preventing any warping or cracking. Following this rapid quench, the rails enter the heat treatment area. Here, reheating furnaces are precisely programmed to perform processes like quenching, tempering, or annealing, depending on the desired mechanical properties. This combination of immediate cooling and controlled reheating not only enhances strength and durability, but also ensures the rails retain their distinctive profile, with sharp edges and clean lines. This stage is what gives the finished rails the power to withstand the enormous, repeated loads of railway traffic while maintaining long-term stability. By carefully balancing temperature and time, engineers grant each rail the resilience it needs to serve for decades. Fresh from heat treatment, the rails move to the welding line, where individual sections are joined into continuous lengths. Guiding rollers and laser sensors work in tandem, ensuring the rail ends align with absolute precision. A high-power arc welder then unleashes intense heat, melting the steel edges as hydraulic pressure forces them together into a seamless bond. Immediately after, an automated grinding system smooths away any excess material, leaving the weld perfectly flush with the rail body. This entire operation is overseen by a central control system that constantly fine-tunes every variable. The result is a joint so strong that its durability matches that of the solid steel itself. This process transforms shorter segments into continuous tracks, stretching for hundreds of meters, ready to carry trains at high speeds with minimal vibration and a strength built to last. Its surface gleams under the factory lights, but its true strength lies hidden deep within. Now, that inner character must be proven as the finished rails enter the quality inspection zone, a place where every detail is subjected to intense scrutiny. A battery of optical sensors and high-speed cameras glides across the entire surface, capturing images with a resolution so fine that even the most minuscule scratch cannot escape detection. This flood of visual data is then processed by advanced image analysis software, which hunts for any deviation in shape, color, or texture. Simultaneously, ultrasonic devices and X-ray scanners peer deep into the steel's core, their mission to uncover hidden flaws like internal cracks or trapped gas pockets. To complement these scans, randomly selected samples are subjected to a series of rigorous mechanical tests. Powerful machines stretch, compress, and press against the steel, while hardness testers measure its fundamental resistance to deformation. Every result is meticulously recorded and stored, creating a digital fingerprint that allows each rail to be traced back to its specific production batch. Only those that meet the full range of criteria earn the final stamp of approval, confirming they are fit for service. Once certified, the rails are cleared for packaging and distribution, ready to be shipped to construction sites where they will form the railway lines of tomorrow. From the factory, their journey out into the world begins. Vast lengths of steel arrive, silent and imposing. Their final placement, however, will be a conversation measured in millimeters. Carried on oversized trailers, each section is bound tightly, a measure to prevent the slightest warp or bend during transit. At the construction site, cranes and specialized forklifts carefully hoist the heavy steel, depositing it into a designated staging area where the human element takes over. Guided by intricate structural drawings, installation teams maneuver each rail into position. Laser levels and surveying instruments cast invisible lines, dictating the precise alignment and gradient of the track before temporary joints are secured with heavy bolts. A constant stream of communication crackles over the radios as workers synchronize their movements to prepare for the final, permanent bonds forged through welding. While heavy machinery bears the immense weight, lifting and holding the rails steady, the final act belongs to the crew. The fine adjustments, the critical alignment, and the finishing touches rely entirely on their coordinated skill. This painstaking effort is what guarantees the stability and safety of the entire system for the decades that lie ahead. Hidden beneath protective coatings and solid welds is the mark of true craftsmanship. In every beam and girder, a story of transformation is told. Each structure represents hundreds of hours of effort, a fusion of immense mechanical power and the focused skill of human hands. Its journey stretches from the mine to the construction site, where it becomes the skeleton of bridges, the framework of factories, and the spine of towering skyscrapers. Looked at this way, steel reveals itself as more than just a material. It is the very foundation of our modern world.